To make testing is greater tractable, what we need to do is we need to reduce this humongous state space into something that's much more tractable. So we're going to use an approach called equivalence class partitioning, which breaks up the state space into smaller regions, and then we can sample from those regions to make sure that we've effectively tested this function. In this case, what we're doing is we're partitioning the input space, because we're only looking at A and B. We're thinking about the input, so this is called input partitioning. You've seen this before in prior courses, where we can range a number, for instance, from negative infinity through 0 to positive infinity. So a number can be anywhere along this spectrum. So prior, you've seen that what you can do when you have a big space like this is you can choose something. Like obviously we want to choose a positive number, and obviously we want to choose a negative number. And then choosing around the boundary is also useful too. So you might choose 0, 1, 5, -1, and -5. Right? So instead of choosing all of infinity numbers to test here, you only have to check these 5 values. So these are the equivalence classes for number. So let's apply these equivalence class partitions to our is-greater function. So we can go -5, -1, 0, 1, 5. And the same thing here, -5, -1, 0, 1, and 5. So in total, here we have 25 options. And over here, we recall we had 1.28 times 10 to the 617th power options. So this is a much more tractable space than this one. And here we still have a very good understanding of what happens when is-greater encounters 2 positive numbers or 2 negative numbers, or a positive and negative number in either option, in either order. So this really does comprehensively test this function without having to exhaustively test the whole space. And this is really the goal of input class partitioning and equivalence class partitioning more generally. Let's take a look at an example from Mario. So the HTML audio manager plays sounds when you're playing the game. So as Mario jumps over enemies or kills people, it's the part of the program that plays the sound effects that you hear while you're playing. So the HTML audio manager can play 2 kinds of sound files. It can play MP3 files, and it can play OGG sound files. So if you think about the state space here, we have all sound files that look like this. So that's all sound files. And the code can run 2 specific kinds. So it can run MP3, and it can run OGG files. So when you're designing your test cases for this system, you don't need to go and test all possible sound files. But we don't need to throw in tens of thousands of sound files at this system. What you can just do is you could say, hey, we're going to run an MP3 file, and we're going to run an OGG file, and we're going to make sure that they actually work. And in that way, we can really cut down this state space for this more complicated functionality. All right, so let's go back and revisit our Mario example. So this is the Mario hit code. And when you're doing black box testing, this is all we know, right? So we have the specification. Right? When Mario lands on an enemy, the enemy takes damage. When Mario runs into an enemy, Mario takes damage. When the enemies run into each other, neither of them take damage. And when Mario jumps on a boss, the boss can still live. And we have the signature itself. Recall that it's just hit that takes a figure and returns a Boolean. And this is all we know. And what we need to do is we need to design a set of test cases with only this information. So what do we actually know here? Right? Because there's a lot of information encoded in just this specification and the API signature. So let's start by taking a look at the parameter. We know the parameter is a figure. And from the spec, we know that we're interested in Mario, and Mario is a subtype of figure. And we can also infer that we're interested in boss. Right? So let's add a boss too. And we need a more generic enemy, so let's work with turtle here. So these are our 3 subtypes of figure. So these are 3 things that we know. And from the specification, we know that there are 2 other properties that are relevant to the correct operation of this function. The first is the direction Mario has. Right? Because if Mario is moving right and walks into an enemy, he'll die. But if he lands on an enemy, the enemy will die. So we have direction. Right or down. And we have state, right? Because if Mario is large, he'll survive walking into an enemy, but if he's small, he'll die. So the state also matters. So let's now turn this into a set of concrete test cases. So if we focus first on Mario, we know that Mario has two properties that we care about, his direction and state. And really this gives us 4 Marios in practice. We have Mario, who is moving right and is big. We have Mario, who is moving down and is big. Mario, who is moving right and is small. And Mario, who is moving down and is small. These are the 4 Marios that we actually care about. And we also have boss and turtle. So let's add boss here and turtle. And from the specification, we also know that this object is always a figure that is not a Mario, right? So we only have boss and turtle. So we can put boss and turtle. So here we can see the truth table for testing the figure hit method. Right, so we have 6 rows and 2 columns. This gives us 12 test cases in total. And if we compare this back to the white box testing we did on the same method earlier, we know that we were able to achieve 100% path coverage with only 6 tests. But that involved going through the code very carefully and really figuring out what was actually happening. Interestingly enough, these 12 test cases also give us 100% path coverage without even seeing the code, right? So we didn't have to do all of that analysis. We were just able to write the test that sort of made sense, and we cover the code really well. This also actually covers other cases that are full path coverage case tests we didn't actually evaluate. And that's also one more way to feel good about how well we've tested this function. From these 12 test cases, we can see how really focusing on the inputs has put our mental state into the what rather than the how. So really focusing on what behavior is invoked by these input parameters rather than how the developer actually wrote the implementation in the first place. And as a user of an API, this is really what you care about. You care about the behavior, not the underlying implementation that really should be hidden from you in practice anyway. Right? So this focus really helps you to make sure that you've tested this in an effective way.